supposed to be covering 1.7 today, but we're going to back up just a second and do finish up a couple of problems in 1.6, okay? So I'm going to pull this to the side. We will get finished with 1.7 today, so no goofing off. All right, so what y'all have, but I don't know where your paper is example 7, find the inverse and verify, right? This is from yesterday's. If you wanted to see on the video, you could. F of x is equal to 5 minus 3x over 2. You found the inverse function, and we did this yesterday, so it's on the video. If somebody were watching and wanted to know what happened, they could go back and find it. Okay, so everybody agree with that? Yeah. Okay, so now we have to verify. So to verify, you're going to find f of f inverse of x and show that he is x, and you're going to find f inverse of f of x and show that he is x. Is everybody right? Everybody good? Okay. So, and how many steps at a time can I do?
One.
What?
One.
One step at a time. One step at a time. So, I'm going to go to the f function. Here is the f function right here. I'm putting f inverse into it. So, this is what I'm putting into it.
Do we have to move, or we can just look?
You can just start working it.
Okay.
So, here's 5 minus 3. In place of this x is what I have to put this. All over 2.
Oh my gosh, why is it gotta be like
Okay, so, what's the first thing I need to do?
redo the problem and give us an easier one.
Yep.
The freeze.
Yes, your 3's cancel out, okay? Now, when your 3's cancel out, you're gonna need to be really careful or you're gonna make a careless mistake, okay? So, 5. Tell me what this is that 5 right there.
Take
okay?
away that negative sign.
That's, y'all, you have to use this negative. This negative has to be distributed here and here. Okay? So you need to be really careful about when you slash stuff that you understand that that negative goes there. While the 3's cancel out, the negative is still there. So the opposite of a negative 2x is a, thank you. And the opposite of a positive 5 is a, now what cancels out?
5s.
Yes. Do not cancel the 2. If you cancel the 2's out here, then you lost all your points.
Yeah, why did
Okay.
you didn't need to do the eggs on the bottom? That's wrong.
The X on the denominator.
Oh. Sorry. Okay. So those are gone, and I'm left with 2x over 2. And who goes away now?
X 2.
And I'm left with my x.
Why do we start with the 3?
That's true.
Because that was the only thing I could do. I couldn't do anything else up here.
Wait, could you distribute this, like multiply?
No, I didn't. I distributed the negative, but I didn't. I canceled the 3's out.
I like the negative things, like when I still have the same.
Yeah. Yeah, you would. Okay. So over here, I'm going to the inverse function. Here's my inverse function. I'm putting f of x, which is this guy, in its place. So I am right here. In place of this x, I put this. So I'll go negative 2. There's an x. Y'all look, that whole thing's on that numerator. All right? So in place of this x, I have to put 5 minus 3x.
Oh my
over
gosh,
2
the table I just finished it. So
plus 5. Okay. All over 3. All right. So who cancels?
6. 2.
Yeah, I'm canceling my 2's. But I still have to remember this negative. Okay? You gotta be careful doing
Yeah,
that.
so my question is, how do you cancel a 2 and a negative 2? Because technically,
How many times does 2 go into negative 2? Negative 1 time. That's a -1 right there, guys.
I got you.
So,
Alright,
okay.
makes sense. I just needed to just.
You could
specification.
multiply by it. What's -2 times 5?
-10.
And what is -10 divided by 2?
Divided by 5. I mean, 5.
-5.
-5.
Alright, which is what's fixing to happen here. Okay? We're fixing to be left with the opposite of this 5, which is -5. And then if you multiply -2 times -3x, you get a positive 6x divided by 2, and there's my positive 3x, which is what I'm gonna get when I change that sign. So it's however you like to do it, it doesn't matter.
These are easy. Do
Okay?
they get much harder?
Now, not really. Now what goes away?
3, 5.
5's again, alright? And so I'm left with 3x over 3. My 3's cancel, and there's my x. Okay?
Would you
Anybody have
count,
a question?
would you count off if we put a 1 in front of that x?
No,
Because sometimes I do that, like not even thinking about it.
that's okay. Alright, so here we go. This is the last one that I want you to work, okay? I want you to find the inverse. And verify algebraically. Okay? F of x is equal to 2x squared plus x minus 7. Alright, so you do that one.
Can you push it up a little bit?
Uh-huh.
It's like right in the head. Thank you.
Mm-hmm.
I used to off a while, but like, what?
Figure it out, guys, figure it out.
Miss Davis, I slept last night. I don't know if you know that or not, but I slept last night. I don't remember.
Well, it's nice that someone slept last night. That's
I
fine.
slept on the couch.
Well, it wasn't very long. But,
I slept at 9, 7:30.
oh my goodness, bro.
Shh, Colton, get to work.
Just
On
good
me.
sleep.
Alright, y'all finished?
No, I can't
No.
start.
Oh my god.
What? You
Oh,
aren't
wait.
finished?
Hold on.
Yeah, this is a problem. What's the first thing I told you you're supposed to check every
1 to
time?
1.
Is it 1 to 1?
No.
This is not a 1-to-1 function.
Yeah.
So it has
I
no
didn't try.
inverse
Oh, Lord.
function.
I said this way.
Bailey was over there grabbing it.
Okay? No inverse function. Alright, so good job. Or not so good job. Alright, whichever one is you.
Bailey, relax.
So here we go. This is going to be a pretty easy section. Now remember what's going to be on your test. All that stuff from 1-6, which is inverse functions. Okay? What we do today, which is linear models and scatter plots.
And
These are
odd and even.
regressions. And even and odd functions. I'll put those on your, they're all on your review. Okay? And I'll give you a review I'll give you a review today. But y'all listen to me. Please don't, we're not coming in here messing around tomorrow, okay? If you finish your review tomorrow, then that's fine, turn it in, okay? But find you something to do, because your test is Thursday, Friday. All right, so scatter plots. This is what I'm looking for when you make a scatter plot, all right? First of all, you must label your axis, okay? You must label your axis. And here's what I'm looking for when you label it. I want to know what it stands for. Okay, for instance, if it were the x-axis and I labeled it and it were time, okay, and what it's measured in. Like, what is the time? Is it in minutes or seconds or hours or years, whatever it is? Does everybody understand? Okay. Your Y is the same way. If it's in height, then tell me what it is. Is it feet? Is it miles? Whatever.
Then do you want that just in parentheses abbreviated?
Or you can just write it with it. I'm okay with it. And then I want a proper scale. Okay? A proper scale. So if my numbers go from 250 to 25,000, please do not start at 0 and go by ones. Okay? That is not a proper scale. Can I change what I go by as I go along?
No.
No. Like between the first 2 tick marks, can I go by 5s? And then they spread out a little more, so, oh, now I'm going to go by 10s. No. Some people think that you can just use the numbers that I give you in the chart. Like, no, people.
Wait, I've got a question.
Okay?
If you can't make a break like anywhere, it has to be by the origin?
Yes.
Okay.
All right. So the next thing we're going to talk about is correlation. All right? Correlation. So all of this stuff that I'm talking about, you should know. I mean, frankly, this is all Algebra 2 stuff. And then we're going to work one problem, but we'll see. So I'm just kind of doing a little refresher. I'm not spending tons of time on it. I would say maybe if you needed more time on it and a better explanation, you might go to the Algebra 2 videos and look up linear regressions or something. All right, so correlation. What kind of correlation is this?
Positive.
A positive correlation.
I remember this.
Very good.
Do we have to tell you if it's strong, moderate, or weak?
We're gonna talk about that.
I can put that in the calculator for you real quick.
Okay, I'm gonna talk about that, but we're not finding, well, I'll talk about it later. All right, so let's do this one. What about that one?
That's a negative.
Negative.
Pretty strong.
Yeah, he's pretty
Probably
strong.
about 0.8.
Ooh, I think he's better than
Yeah,
that.
0.9, right?
Yeah, probably.
What?
What is ours?
No.
Okay,
Uh-oh.
and the last one?
That might be.
That is what you call very,
Whack.
neutral.
Okay, this is no correlation. All right, so here's what I want you to do. I want you to label these graphs. This is A, this is B, and this is C. Okay? So, let's see, a positive correlation. A positive correlation might be how many hours you spend studying for a test and your grade on that test.
False.
Okay? So, the longer you study, the higher your grade. Right? It's not always true,
But
okay?
for the most part,
For
it's
the
gonna have
most
a
part, it
positive.
is an inevitable positive correlation.
What about outliers?
Listen, there are some outliers, okay? So, but there's always gonna be outliers, people, because we're not a perfect
I'm an
world.
outlier.
But listen to me, this is important to know, is there a point in here where you've studied, and you studied maybe more than you usually studied, but you made your grade worse? Because you studied enough to confuse yourself? Do you understand? You need to know what that is, guys. High school's a place to learn about that, okay? You need to know that kind of stuff before you go to college, because you don't want to be bombing a college test, all right? Sometimes those professors only give a midterm and a final.
My brother passed his first business calculus class, and he didn't even take PreCal in high school.
Very good.
Yeah, we were proud of him.
Very good. All right, a negative correlation. This is how many hours you spend playing on your telephone, okay, and your grade on the test. Okay?
That's a positive correlation.
So, that's what, you spend a long time playing on that stupid telephone, and your grades are gonna go down. All right? No correlation. Shh. No correlation.
Marshmallows you eat.
Yeah, how many marshmallows you ate and your grade on the test? How many times you had to let the dog out last night and your grade on the test? Okay? All right, so here we go. correlation, shh, hey, I'm recording, so don't be annoying to the people trying to watch. Correlation coefficient. Okay, correlation coefficient. The correlation coefficient is R, okay? And R is between -1 and +1 inclusive. All right? The sign of R tells the type of correlation. Okay, so if R is positive, then obviously I'm going to be talking about a positive correlation. If R is negative, I'm going to be talking about a negative correlation. The closer the absolute value of R, so I'm going to take the sign off of it, I'm just going to talk about the number. Okay, so I'm just talking about the number R. I've already told you what his sign represents. Okay, so let's talk about this number. The closer the absolute value of R is to 1, the tighter the fit. Or the closer the points are to the line of best fit. Okay? So, the closer that this number R, without a sign, so I'm going to take the absolute value of it, the closer he is to 1, then the tighter I say the tighter the graph, the tighter the fit, or the closer that your points, all your points are going to be to the line of best fit. All right? We are going to round to 3 decimal places. If you don't, you'll lose points every time you do something. All right? How many decimal places? 3. Every time, people, 3 decimal places.
What is that abbreviation?
Points.
Places.
Points. 3 decimal points. 3 decimal places, I guess it should be. But the third decimal number behind the decimal. Now you make me feel weird about the way I say it.
I'm sorry.
That's the way I say it. Is that not right?
No, it's right. It's just
It sounds weird.
The points.
Okay, so here's what I'm going to do. I'm going to talk about some R's. I'm going to give you some R's up here. I'm making these up, people. I am making these up. Okay, I didn't get these anywhere. All right, I know some of y'all talked about this stuff in stats. In stats, you actually find R, right? Okay, we're not going to. The calculator's going to find R for us, so we don't have to worry about that. So I'm just making some up. They're going to correlate to these graphs up here. All right, and you're going to play the matching game, not out loud, and you're going to tell me which number goes with which graph. Okay, so give everybody a chance to work these problems. Okay, I didn't put the sign on there because if I put the sign on there, then, I mean, you all would have said, oh, I know where it goes. And you would have been looking at the numbers, but you would have been looking at the, just the signs. Okay, so I want to know which one of those numbers goes with graph A, which one of those numbers would be most likely to go with graph B, and which one of those numbers would be most likely to go with graph C. All right, you got it?
No idea.
What? Which one of these numbers is the closest to 1? This one, the first, second, or the third?
First.
Okay, so this guy is the closest to 1. Which one of these graphs would be the tightest or fit the
B.
closest to the line of best fit?
B.
Yeah, y'all look, a line of best fit, if I drew a line of best fit, you would go like this. Okay? You see how tight those points are, how close they are to my line of best fit? He's very close to 1. Okay? He's very close to 1. All right? Now, who's the next closest to 1?
R,
Yeah,
A.
this guy right here. And that would be this guy. All right? So if you draw a line of best fit here, yeah, I'm following the points, but are they very close to my line? They're kind of spread out, okay? They're not very tight in there with that line. So I would say this one was A. Okay? Now, people, this is not even close to 1. Okay? I would look at this and say, you have nothing. You have nothing, okay? Which one is no correlation?
The last one.
Now, does that make sense? Okay, so again, I want to tell you that we're not finding R, okay? Your calculator is. We are also going to use our calculator and we're going to find what's called R squared. And he is the coefficient of determination. Coefficient of determination.
Can you move it up?
Mhm. Coefficient of determination. And y'all, he is actually this R up here, and it's squared. That's what it is. And that's why they call it R squared. And it kind of ends up being like the percent of points on the line of best fit. Okay? Now, I am going to tell you this, that sometimes, today, we're only doing linear regressions, all right? So linear regressions are going to give you an R and an R squared. Sometimes when you do a regression on a curve, it will not give you an R, it will only give you an R squared. So that's why I like to use the R squared, because eventually what we'll do is, as we get on into this semester, we will start comparing, you know, would this be a better fit for a line of regression, or should I put a curve on this thing, all right? And you're not gonna look at how good it looks, because we don't go by looks, but your R squared, you're gonna look at your R squared and see who's closest to 1. That's gonna tell you how best it fits. Okay? Not which one looks the best, but which one actually fits the best because of the numbers. Okay? All right, anybody got a question? Okay, so here's the next thing that I want you to do. The next thing we're going to do, I'm not writing all this over again, y'all, so I'm just kind of cheating. I don't very often cheat in here, but I am today. All right? So, these are the rules for a regression on a calculator. Okay? These are the rules for the regression on the calculator. So you should know these. Wait, that's not all of them. There's a 4 down here. They won't all fit.
So we're
in.
writing these down?
Yes, but I would put them in my notes.
Okay.
Okay? I'll go over them with you. I just didn't want to write them again. All right? So the rules for the calculator. This is Roman numeral 1. It's kind of hard to see it. It's right there. So I got Roman numeral 1, 2, 3, and 4. There's 4 things you have to do. All right? So Roman numeral 1 is turn your diagnostics on. When you turn your diagnostics on, that's going to give you an R and an R squared. Okay? If you do a regression and your R and R squared don't come up, guess why? You didn't turn your diagnostics on. Okay? You didn't turn your diagnostics on. So there's 2 ways to do it. This used to be the only way I knew how to do it. This morning, Bo taught me how to do it this way. It's so stinking easy. Okay?
So should we write it that way?
Yeah, I would, because it's easy. You just go to mode. I'll show you what it looks like. Okay? You go to mode right here. And he said it's down at the bottom, but on our calculators, it's actually on the 2nd page. Okay, so I arrow up and it takes me to the 2nd page. And then when you go right here, you see where it says Stat Diagnostics. You can turn them off or on right there. Okay, so that's, and then you're just going to go 2nd and quit and get out of there. All right, is everybody okay? The 2nd Roman numeral, this is the 2nd thing that you're going to do. You're going to input your info. So you're going to go to Stat, and edit. You're gonna put your X's in list 1, your Y's in list 2, and then you're gonna quit.
What do you do if you don't
Can you
have
go
a
back
list?
up?
Look, you don't have to write this down, guys. I mean, look, if this way's easier, heck, let's do this way. I mean, they're doing the same thing. Like, we're gonna dig a hole. You're gonna use a shovel or a spoon.
Really depends on the kind of hole. Like post holes, spoons work really good.
No, a spoon, a post hole digger would be.
Well, yeah, but if you were only given a
Okay,
spoon.
but not a
so-
spoon, no. You're gonna dig a 3-foot hole with a spoon? No, please.
Well,
Eli.
I know what to do.
I'm just telling you, bro.
No, copy, go. Write your stuff down. All right, everybody finished with the input info?
No.
Come on, hurry up.
Alright, so Miss Davis.
Okay, regression. To do a regression, you're gonna go stat, you're gonna arrow to the right to calc. You're gonna choose number 4 right now because we're doing a linear regression. Our linear regression is in this form, AX plus B. There is another one. I picked this one, okay? Then after you do that, you're gonna arrow down to store regression equation, and you'll press alpha F4, and then choose Y1. We're gonna store our equation in Y1 so that when we graph it, it'll pop up on our screen. Are we taking more notes after this? We're just gonna work a problem. Okay? Colton, are you all caught up?
Yes, ma'am.
All right, the last thing. Oh, you also, after you do it in Y1, you have to arrow down and go to calc and then press enter. Okay? Because that's going to calculate the regression equation. Do y'all remember this from algebra? Y'all, you do it in algebra 1. Surely by the time you get to PreCal, you know how to do it.
I remember this in stats.
Okay, so the last thing you're gonna do is we're gonna look at a graph. So you're gonna go second and stat plot. That's the Y equals button. You're gonna choose one. It's gonna have stat plot 1, stat plot 2, stat plot 3, whatever. You just choose one. You're gonna turn it on, and then you're gonna choose the type of graph. You're gonna choose where you put your X's. Are you gonna put your X's and your Y's? And you're gonna choose what kind of mark you wanna make on your graph. Then you're gonna go directly to Windows. The mistake kids make is after they choose all this, they just go graph, and then they go, oh, Miss Davis, my calculator's broken. It's not showing my graph. Like, cause you're not looking at the right place. So you're gonna go to Windows and put in your appropriate windows, and then you can graph it and look at it. All right, everybody okay? Everybody finished? Nobody's saying anything, so I'm saying yes.
Yep. Graph.
All right. So now we're gonna work a problem. Okay? So this is actually example 3 out of your book. Okay? And it's gonna give me a chart. Okay? The left side of the chart is going to give me the year. That's going to be my time, T, okay? And the right side of the chart is gonna give me the number of people. We're gonna call that P, and it is actually going to be in millions. Now that's important to know, isn't it? Okay, so I will call the chart out to you and you can write it down.
Wait,
How many are there?
1, 2, 3, 4, 5, 6, 7. Left with 7.
Just say this, what is that other second, the second?
P,
No,
in
how about
millions?
the- okay,
hashtag number,
Thank you.
hashtag number.
hashtag people.
Pound sign. Pound sign.
Pound sign.
Tic-tac-toe.
It's number. It's a number symbol. It means
Pound.
number.
No.
It's a pound symbol.
It's called a pound symbol.
Okay, here we go. The first one, 1995. Remember, we're using an old book, okay? So our data is a little bit older. 1995, 132. That's million people, all right? 1996. Oh, I didn't even tell you what these people were doing. These are people with frog feet. I'm just playing. These are people. These are the people. People in the workforce. Okay, these are the people in the workforce. All right, so these are the people working. So, 1997, 136.
Oh, I see a pattern.
Oh, 1998, 138. Does
They're
it
going
look?
up by twos,
It
Lizzie.
looks like it's very linear, doesn't it? Okay? But then 1999 rolled around and 139 people.
That's when you were born, Miss Davis, right?
What?
1991?
Yes, I was born in 1999.
Or are you 130? Only one of these will be right.
2000, 141. And 2001, 142. They're gonna do, okay, you could, if it just told you this, you could do whichever one you wanted to. So if you put 1995 in your calculator, you wouldn't do anything, you just write your answers. If you chose to use 95, then you would need to tell me that, okay? It's not going to change the slope of the line, but it will change the y-intercept of your line, okay? But they put a stipulation on this one. They said, hey, let t equal 5 represent 1995. Okay? Let t equal 5 represent 1995. So they put this stipulation on in the problem. So the first thing I want us to do is I want us to graph this thing. Obviously, he's going to take place in the first quadrant, all right? Because he is a real life problem. What's the first thing I should do with my graph?
Label your axis.
Label my axis. What does the x-axis stand for? The year. Okay? And am I going to list it as 1995, 1996?
No.
I'm not. I'm going to do what they told me to do. Okay? And they said let this represent 1995. So I need to put that down here on my label. T is equal to 5 represents 1995. Sometimes you'll see it written like this. Okay? I don't care which way you write it. Whatever makes you happy. All right? What about my y-axis? What is it? Number of people in the workforce. Anything else I need? In millions. People, if you don't put in millions, they're like, wow, come on. In millions. Okay, so 5. What's the next guy?
6,
And then,
7, 8, 9, 10, 11.
okay, So that's what I'm going from and to. Does everybody understand? Do I need to start at 0 and go to 1? No. It says let's start at 5. All right? Now, if I'm starting at 5 and the next tick mark is a 6,
You need a break.
I need a break. We need a Kit Kat. No, I took part of the
A
graph
break?
out, 0 to 5. I broke that off, okay? So you have to put a break mark in there. Then we go 5, 6, 7,
8,
8.
9,
Yeah, I probably need some help numbering, right?
10.
And
11.
11.
I think we-
Almost wrote 12.
You said,
I
you're
almost wrote
welcome,
12.
you're welcome.
Thank you. All right, now, my Y's, they start at 132 and go to 142, okay? So what do you, I always like to choose what I'm gonna go by first. What do you wanna go by?
2.
Okay, I like 2s. What do I wanna start at?
130.
I can start at 132, okay? But if I do that and I'm going by 2s, what do I have to do?
Break.
Yeah, you gotta put another break in there, okay? It just looks like a little heartbeat. So this is 132, this is 134, 36, 38, 40, 42. And then I'm just gonna plot my graph. Does everybody agree?
Yeah.
So 5 is 132, 6 is 134, 7 is 136, 8 is 138, 9 is 139, so he didn't quite go up like the other ones did. 10, which is 2,000, is 141, and 11 is 142. Okay, so there's my scatter plot. Everybody okay with that one?
Yeah.
Alright, so now I'm going to use the directions that I have. If you're using one of the class calculators, if I were you, I would, it's probably, mine's going to be in there, okay? So, look, I'm following, I was like, where did this go? I'm following these directions that we wrote down, right here. You see them? Okay? That's all I'm doing is reading. Those are just directions on how to work my calculator. Okay? So first thing I'm going to do is I'm going to make sure my diagnostics are on. So I'm going to go to mode. I'm going to arrow up to get to the second page. There's my diagnostics. And I'm going to turn mine on. Mine are already on. Okay? So now I go second and quit. Now I'm going to put my information in. So I go stat. I'm already on edit. I'm going to put my X's in list 1 and my Y's in list 2. I'm going to leave my Y's in list 2 because I've already done that. But I'm going to show you this. Okay, I'll clear these out because they'll be easy to put back in. If you need a list, if you have a list and you need to clear it out, you go up on the top and then you press clear and enter. And it will clear the whole list out. Okay? If by chance somebody deleted one of your lists or something, you can go stat and go down to number 5, the setup editor, and he will pop your list back in the order that they're supposed to be in. List 1, list 2, list 3, list 4. Okay? So, I'm going to go back here to edit. I'm going to put my X's in list 1. You put your X's in list 1 and your Y's in list 2.
What if mine's accidentally backwards?
What? I just told you how to fix it if your lists are messed up. Go to the setup editor. All right, everybody okay? Now, I'm going to tell you some things that I do. One thing that I always do is after I've put my stuff in, I always look and make sure that I have the same number of X's as Y's. If you don't, like you know how sometimes you get going really fast punching those numbers, and instead of getting 2 and 3, you'll get 23, and then you'll have more Y's than you have X's. When you try to run a regression, it'll say a dim mismatch. That means your dimensions don't match. You have more in one column than you have in the other, and he doesn't know what to do with it. So I always just stop and check mine right here, and I go same number of X's and Y's. So hopefully I'm okay. All right, so now I'm here. I'll go second and quit. And now I'm going to run a regression. Okay, so I'll go stat. I'll arrow over to calc. I'll choose number 4 by pressing number 4. That's my linear regression in the form of ax plus b. I'm going to, it's asking me, did you put your x's in list 1? Yes. Your y's in list 2? Yes. I have no earthly idea what a frequency list is, but I asked Mr. Ryan when they first came out with this new kind of stuff that they did, when they did an upgrade on our memory, and he didn't know, so I figure it must not be that important. All right. Then I want to go to store regression equation right here, okay? I want to store my regression equation in Y1 so I can see it on my graph. If you leave this blank, it'll still calculate it for you, but you won't see it on your graph. Okay, so if I were in a hurry and they weren't checking my calculator or something, I didn't care about that, then I would just go down to calculate, press enter. But I want mine to store mine in Y1. So I'm going to go alpha, that's the green key, and they give me these green letters up here, F4, and I'm choosing Y1. If you had 1 in Y1, you could put the next one in Y2, and that way you could compare them what they looked like. Okay? Then I go down to here to calculate. I'm right here on my paper. Okay? And I'll press enter. So this is my equation. What are we rounding off to?
3 decimals.
3 decimal places. So over here, what I'm going to do is I'm going to write it. Y is equal to, what is A rounded off to 3 decimal places?
1.679.
1.679x plus 124. Are you with me?
Yeah.
All right. I'm going to go ahead and write r squared and r down because I don't know what they're going to ask us on the test or the worksheet. So r squared is equal to, round it off to 3 decimal places and tell me what you get.
0.99.
3 decimal places.
0.990.
Very good. 0.990. That is rounded off to 3 decimal places, people. Okay? What about r? 0.995, right? Okay. Now, the next thing that I want to do is, let me look and see. I asked a question. Can you use yours? Oh yeah, we're going to graph it. Sorry. And so now, here I am. I forgot about that. I'm right here. Okay, so I'm going to graph it. So, I'm going to go to second and stat plot, which is y equals. All right? I'm going to choose one of them. You see you have like, I don't know, 9 or 10 of them. I'll choose the first one. I'll turn him on. I'm going to choose the type. This is a scatter plot. This is a line graph. This is a bar graph. These two are box and whiskers. This is the box and whiskers. Yours is you're familiar with because it has a median line. This is step graph, I think. All right. Then my X's are in list 1. My Y's are in list 2. So I chose the type. This is scatter plot. Okay, so if it was on something else, I would choose this one. My X's are in list 1, my Y's are in list 2. If I needed to change that, this is the way you change it. Your list 1 comes from second and 1 is list 1. Second and 2 is list 2, second and 3 is list 3, and so on. All right? So I like the mark of a square. You could choose any mark that you wanted to, but I like the square. Now I want to go to my windows. Don't just go graph, people. You want to make your graph. I want my I want my graph to look exactly like the one. Okay? I want my graph to look exactly like the one on my paper. Okay? So I'm going to go to my windows. Now, my X's go from 5 to 11 on a scale of 1. All right? But I don't like my stuff hanging on the edge of my calculator, so I always go from 4 to 12. But you could go from 5 to 11. It wouldn't be a big deal. So 4 to 11, and I am going on a scale of 1. My Y's go from 132 to 142, but I'm bumping it down 1 and up 1. So I'm going 130, to 144, and I am going on a scale of 2. Now my graph should look just like this graph right here, except it's going to have the line of best fit on it. I can see that he looks like a very good fit. My R squared and R tell me he is a very good fit. Here's my next question. Predict how many workers are in the workforce in 2004. Okay? Predict how many workers are in the workforce in 2004. Well, first of all, can I put 2004 in here for X?
No, you have to put 14.
All right, so T equals 14.
147 million.
147.506 million.
500,000.
Gotta have the million on there, okay? So here's what you're gonna do. This is part of your review. Page 78 through 79, 11 through 14. Okay? If you need to take a picture of that, you're more than welcome to. Your reviews, if you want them, are on that back corner. You're more than welcome to get them. Travis, will you stop that video, please?
You know you're not gonna look at the picture. Why don't you take it?